Alright, this is topic 6.12, integrating using linear partial fractions. And here is another integration method that is beyond the scope of AP Calculus AB, but it is in BC. So let's think back to what are linear partial fractions. Okay, say I have the 1 over x squared minus 4. But what if I want to break this down into separate fractions where I can have a linear term in the denominator? Well, notice that I can factor this by the difference of squares to get 1 over x minus 2 times x plus 2. And this is where linear partial fractions come in. We can write this as being equal to a over x minus 2 plus b over x plus 2, where a and b are just random arbitrary values that we are assigning. Now what I can do is I can say 1 over x minus 2 times x plus 2 is equal to a times x plus 2 plus b times x minus 2 over x minus 2 times x plus 2. Notice how I just got common denominator so I could combine my fractions. Now notice I can say a times x plus 2 plus b times x minus 2 equals 1. Alright, well, what if I let x equals 2? If I let x equal 2, then a will equal, well, let's see. I'd get 4a equals 1, and I'd get a equals 1/4. And notice how I chose a convenient value of 2, because that eliminates my b variable that I have to solve for. So, if you can think what I'm going to choose for my second x value, you're probably thinking right, and yes, it is x equals -2, because that will eliminate my a variable. And then I'll get, well, that's just going to be -4b equals 1, and b must equal -1/4. So therefore, I could write 1 over x minus 2 times x plus 2 as being equal to 1 over 4 times x minus 2. And then that really should not be a plus. It's going to be a minus 1 over 4 times x plus 2. And we're about to see how this is going to be useful for integration. So let's do some practice problems. Say I have the problem, the integral of 1 over x squared minus 2x minus 8 dx. Well, think about the traditional methods that we may use to solve this. It doesn't look like any of them would work. Use substitution, integration by parts, completing the square. Doesn't look promising. But notice I can factor the denominator. X minus 4 times x plus 2. Now I can use linear partial fractions. 1 over x minus 4 times x plus 2 equals a over x minus 4 plus b over x plus 2. I can say a times x plus 2 plus b times x minus 4 equals 1. Now, if I let x equal 4, my b cancels, and I will get 6a equals 1, so a must equal 1/6. If I let x equal -2, then my a will cancel, and I get b equals -1/6. So now notice what I can write. I'm going to have the integral of 1 over 6 times x minus 4 minus 1 over 6 times x plus 2 dx. And now notice I can separate these and factor out a 1/6 to get 1/6 integral 1 over x minus 4 dx minus 1/6 integral 1 over x plus 2 dx. Now this is a common ln, and all I'm going to do is integrate 1/6 ln absolute value x minus 4 minus 1/6 ln absolute value x plus 2. Oopsies, that should be absolute value. Notice I can factor out a 1/6. And properties for logs. So we've learned that ln of A minus ln of B equals ln of A over B. It's actually the same for exponents. So the ln, the absolute value of A, minus the ln of the absolute value of B simply equals the ln of the absolute value of A over B. So I can rewrite this then as 1/6 ln absolute value of x minus 4 over x plus 2. And the most important part, do not forget your c. So that's a basic example of using linear partial fractions to solve an integral. We're going to do a couple more examples so we get practice. The next example I have is the integral of 3x squared minus 7x minus 2 over x cubed minus x dx. Now, don't get intimidated that there is not a constant in the numerator. That is okay. Let's first factor this to get 3x squared minus 7x minus 2 over x times x squared minus 1 dx. Notice I have a difference of squares, so I can do the integral of 3x squared minus 7x minus 2 over x times x minus 1 times x plus 1 dx. Now, I can break this up. I can say a over x plus b over x minus 1 plus c over x plus 1 equals 3x squared minus 7x minus 2 over x times x minus 1 times x plus 1. Now, this is where it gets crazy. A times x minus 1 times x plus 1 plus b times x plus 1 plus c times x minus 1 equals 3x squared minus 7x minus 2. All right, looks quite daunting, but it's really not. So first thing I'm going to do is let x equal 1. Now, notice if I let x equals 1, my a goes away, and my c goes away. And then I'm left with 2b, right? 2b equals 3 times 1 squared, which is 3, minus 7, which is negative 4, minus 2, which is negative 6. And therefore, b must equal negative 3. Then I'm going to let x equal negative 1. Well, what happens then? My a term cancels, my b term cancels, and I'm left with c. And specifically, I am going to have 2c, right? Yep, 2c equals 3 plus 7 this time, which is 10, minus 2, which is 8, and therefore c must equal 4. Lastly, I'm going to let x equal 0. That will cancel my b and c out, and then I get a equals negative 2. All right, so I can rewrite this then as the integral of negative 2 over x dx minus the integral of 3 over x minus 1 dx plus the integral of 4 over x plus 1 dx. I can take out these constants, negative 2 integral 1 over x dx minus 3 integral 1 over x minus 1 dx plus 4 integral 1 over x plus 1 dx. Now these are all simple ln, and I'm going to get negative 2 times the ln of the absolute value of x minus 3 times the ln of the absolute value of x minus 1 plus 4 times the ln of the absolute value of x plus 1 plus c. And that is going to be my final answer. Now, let me just make sure of something here. So we have yes, this should all be correct. Yep. So if you have any questions with that one, just let me know in the comments. I think that's all correct. I don't know, something just seems a little off, so I know what's off. When I let x equals 0 here, it's negative a equals negative 2, and therefore a actually equals 2. My bad there. So this is really plus 2, and this negative can just go away. So let me get out my eraser. There we go. That's the correct answer. I knew something felt off. All right. So let's do one more example because these are long problems. Let's do the integral of 5 over x squared plus x minus 2 dx. All right. So I immediately know I can factor this. X plus 2 times x minus 1 dx. And I'm going to say a over x plus 2 plus b over x minus 1 equals 5 over x plus 2 times x minus 1. A times x minus 1 plus b times x plus 2 equals 5. If I let x equals 1, then I will get 3b equals 5, and b will equal 5/3. If I let x equal negative 2, I get negative 3a equals 5, so a equals negative 5/3. So now I'm going to have the integral of negative 5/3, which I'm going to take out, 1 over x plus 2 dx, right? And then plus 5/3 integral 1 over x minus 1 dx. Now, one thing I'm going to do is rearrange this, get 5/3 integral 1 over x minus 1, and you'll see why. Minus 5/3 integral 1 over x plus 2 dx. Now, when I integrate this, I'm going to get 5/3 ln of the absolute value of x minus 1 minus 5/3 ln of the absolute value of x plus 2. Don't forget our c when we get to the end there. Factor out of the 5/3, and this becomes ln of the absolute value of x minus 1 over x plus 2. And then all I have to do is I do plus c. And that right there is my answer. All right, if you guys have any questions, just leave them down below in the comments, and I will make sure to respond to them. All right, stay tuned for the next video.